This video is on section 3.1, quadratic functions and inequalities. So the first thing we're going to do in these notes is look at quadratic functions that are written in standard form and learn how to convert them into the vertex form. And the way that we do that is by completing the square. And in your book, it doesn't say convert into vertex form. This is the common way that most people phrase these questions. In your book, it tells you specifically to convert it into the form that looks like y equals a times x minus h squared plus k. And they refer to it as this form, but the name of that form is vertex form, which is why that's how I wrote the instructions. Okay, so the first thing I do is I'm just going to think of this as a y. It's how my brain works. And I'm going to take the number on the end, I'm just going to subtract it over. So it's kind of like completing the square when we were solving and we had an equation that equaled 0. So y minus 2 equals, and I'm going to write x squared plus 6x, and I'm going to have the blank, just like I always did with completing the square. And then I'm going to do the process. So 6 divided by 2 is 3. 3 squared is 9. And so 9 is the number that completes the square. And since I added 9 to the right side of the equation, I'm going to add 9 to the left side of the equation as well. So I have y plus 7 equals, and then this is where I have my parentheses squared. And whatever I got when I divided by 2, that's always what goes in the parentheses. So it's x plus 3. X plus 3 squared. And then to have it in vertex form, so it's something that I could graph, I would just take that plus 7, I would subtract it over to the other side. But it's not really y, it's actually f of x. I'll keep the function notation. And if you don't mind leaving it as f of x through the whole problem, then you can. I don't like it. Okay, so let me try this problem. First thing, I'm going to take that 45, I'm going to subtract it over to the other side. So y minus 45 equals, and then we have 2x squared minus 20x. And so this is one of those problems that has a coefficient, and so we have to take that coefficient out. So I'm going to do 2x squared minus 10x plus the blank. Okay, so now that I've taken that coefficient out, I can do the completing the square process. And that coefficient happens to be 2 in this case, but it could be anything. So here I'm going to do negative 10 divided by 2. And remember, this part where I divide by 2 and then square it, that's the same on every problem. It's not because there's a coefficient here. The fact that these are both the same number is a coincidence. That's not how it's always going to work. Okay. So negative 10 divided by 2 is negative 5. And then negative 5 squared is 25. So 25 is the number that completes the square. But I did not actually add 25 because there's a 2 in front of my parentheses, and that 2 would be distributed. So I'm going to do this in a different color so you guys can... This I would recommend doing in a different color on your notes so that it draws your attention to it and you don't forget. I actually did 2 times 25, so I actually added 50 to the right side of the equation. And so for that reason, I'm going to add 50 to the left side of the equation. So I have negative 45 and 50, which is 5, and then 2 in my parentheses squared. And just like before, whatever you got when you divided by 2, that's the number that comes into these parentheses here. So I have x minus 5 squared. And then I can go ahead and get my y alone. I'll just take this 5, subtract it over to the other side. And it shouldn't be a y, it should be a g of x at the end. Okay, so here, same thing. convert it into a vertex form, but we're going to add an extra step. We're going to graph it when we're finished. So I'm going to start off by moving the 9 over to the other side. I'm thinking of the h of x as a y. Just like this one, we have a coefficient, so I'm going to go ahead and take that coefficient out. So when I divide by 2 to get the coefficient out, that's what I'm left with, and I have my blank. And then I'm going to take the middle term and divide it by 2 and square it. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So 4 is the number that completes the square, but I didn't actually add 4 to the right side of the equation. I actually added 2 times 4 to the right side of the equation, which means that I really added 8. So negative 9 and 8 gives me negative 1. And I have 2 times parentheses squared. And whatever I got when I divided by 2 is what goes in the parentheses. So x minus 2. And then I can go ahead and take this negative 1 and just add it to the other side. So y equals 2, x minus 2 squared plus 1. Okay. Now we're going to graph these. So that means that we have to know how to graph these. So I'm going to use this as an opportunity to practice using my transformations to graph a quadratic. So the points for a quadratic are negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. And the reason I know that's what they are is because negative 2 squared is 4. Negative 1 squared is 1. So I'm just thinking about using the parent function, the most basic version of the function, y equals x squared, to think of what my points are. And then for the transformations, I know that we have a vertical stretch of 2. Vertical stretch of 2. Right 2 and up 1. Okay, so since this is what we have, I'll go ahead and take these points and I'm going to do these transformations. So a vertical stretch of 2 is going to take all of the y coordinates and multiply them by 2. And then I'm going to shift all of the points to the right 2. And then I'm going to shift all of the points up 1. So there's some of these points I'm not going to be able to graph. 0, 9, I can't, but 1, 3, I can graph, and 2, 1, I can graph. And 3, 3 I can graph. So this is a pretty narrow graph because it's been vertically stretched. So there is my graph. Okay, let's look at this other one. So this is my y. I'm going to take the 3 and subtract it over to the other side. And this one has a coefficient that happens to be negative, so I'm going to take out the 2, but I'm also going to take out the negative. And then I'll go through the process of completing the square. So 2 divided by 2 is 1, 1 squared is 1. So 1 is the number that completes the square, but I didn't really add 1 to the right side of the equation. I actually did negative 2 times 1, so that's actually negative 2. Okay, so we have y minus 5 is negative 2 parentheses squared, and then the number that I got when I divided by 2 is what goes in the parentheses. and then I'll just add the 5 over. And for each of these, technically, I should be rewriting this as h of x and k of x. Okay. So for our transformations, we've reflected over the x-axis, vertical stretch of 2, left 1, up 5. Okay, so I'm going to take these same points. I can do the reflection over x and the vertical stretch of 2, that -2 in the front. I can do that at the same time. So I'm going to take the x coordinates, keep them the same, take the y coordinates, multiply them by -2. And then I'm going to shift all the points left 1 by taking the x coordinate and subtracting 1. And then I will shift all the points up 5 by taking the y coordinate and adding 5. Okay. All right, so next we're going to look at the opening, the vertex, and the axis of symmetry. So these are just some characteristics of quadratic functions. They just kind of describe quadratic functions. So we can see here that from this vertex form that if the a value is positive, the vertex well, the vertex is down here, but the quadratic opens up. If the a value is less than 0, if it's negative, the quadratic opens down. You can see from here that the vertex is hk, so it's the opposite of whatever the h value is, and then it's the same as whatever the k value is. And then the axis of symmetry is just saying what's the line that cuts the vertex in half. So what line could you fold the or cuts the parabola in half, excuse me. So if you had this drawn on a piece of paper and you were to fold the paper in half through the vertex, what is that line called? So for the opening, if the a value is greater than 0, then the graph opens up. If the a value is less than 0, then the graph opens down. The vertex is hk, and we know that in the equation it says x minus h, so when I say hk, I mean the opposite sign of whatever that number is. And then the axis of symmetry is a vertical line that goes through the vertex, and so since it's a vertical line, it's going to be an equation x equals some number, and since it goes through the vertex, it's going to have to be x equals the x coordinate of the vertex, which is h. So if we were to take that information and apply it to this problem to find the opening, vertex, and axis of symmetry for this, I would look first at this a value of -1/2, and I'm going to say a is -1/2, and so a is less than 0, and that means that this graph opens down. It's an upside down graph. The vertex is -5, -3. And the axis of symmetry is the vertical line that goes through -5, -3, and so it's the equation x equals -5. right? Here is a quadratic equation in the standard form, and we can get the same information, it just looks a little bit different. So the opening is nice, it's still the A value, so we're still going to see if A is positive or negative. You know that the graph opens up for positive values and down for negative values, so that's the same. The vertex is a little bit different. We have a formula here to find the vertex. So to find the x-coordinate of the vertex, you're going to use the formula negative b over 2a. And then to find the y-coordinate of the vertex, you're going to plug in that x value into the function. So the vertex is going to be negative b over 2a for the x-coordinate. And then for the y-coordinate, you just plug in whatever that number is into the function, and then it will give you the y-coordinate. The axis of symmetry is still that vertical line that goes through the vertex and cuts the parabola in half, and that's x equals negative b over 2a. Okay, so for this example down here that's written in the standard form, we have our a value is negative 2. And so since a is less than 0, that means that this graph opens down as well. The b value is negative 4. So if we do negative b over 2 times a, that would be the negative version of negative 4, which is just 4. 2a would be negative 4. And so the x-coordinate of the vertex is going to be negative 1. So our vertex has an x-coordinate of negative 1. And to find the y-coordinate, we're just going to take our calculator and plug negative 1 into the equation. So I like to do it, I'll explain what I'm doing, by typing in negative 1 and then storing it, STO, storing that as x. And I like to do that because then I can just type the equation and it will plug it in for me. So negative 2x squared minus 4x plus 3. Plugged it in for me and it got 5. And then our axis of symmetry goes through the vertex, and so that's x equals negative 1. Okay, so this next page has a couple examples, and it's asking us to find the characteristics of a quadratic function. And some of these characteristics are familiar to us, some of them we just learned, and then some of them we'll kind of look at more in depth in this example. So it says, for each parabola, determine whether the parabola opens up or down. So we can do that pretty quickly. The a value here, a is negative 1/2. So a is less than 0, which means that this opens down. Find the vertex. The vertex is negative 4, negative 8. Find the axis of symmetry. That's going to be x equals negative 4. Find the domain and range. So we know that this is a U-shaped graph. We know it's opening down, so it looks something like this, with a vertex right here of negative 4, negative 8. Okay, so the domain, the graph goes left and right forever. For the range, the graph goes down forever and goes up to negative 8. Okay, find the maximum and minimum values. So there's no minimum value because this graph goes down forever, and we can't say, oh, the minimum value is infinity. So we're going to say none. The maximum value is found here at the point, so we can say the maximum point would be -4, -8. The way that they phrased the question when they said the maximum value means that they want the y coordinate. So there's two ways you can answer this question. You can say where the maximum is. The maximum is located at x equals -4. What is the maximum? The maximum is -8. So depending on how they phrase the question, you might use just the x coordinate to answer, just the y coordinate to answer, or both coordinates to answer. So we're going to say that the maximum value is -8, which happens at x equals -4. So that answer can vary depending on how they phrase it. The intervals on which the function is increasing or decreasing. So I'm going to picture my little stick figure. He is walking uphill, and then he gets up to the top, and then he is going downhill. And if I label all the x values, this is a left arrow, so that's -infinity. This is a right arrow, so that's +infinity. And then the x value in between is the -4. So increasing is -infinity to -4. Decreasing is -4 to infinity. Okay, and then we want the intercepts, and so we have two types. We have x-intercepts and y-intercepts. The y-intercepts are always going to be the easiest to find. You just plug 0 in, and so I'm going to say 0 stored for x, because I'm going to plug that in, and then -1/2 times 0 plus 4 squared. -8. Well, I just plugged in 0. I could have typed it in as an x, though. I guess that one was easy to plug in. Okay, so the y-intercept is -16. Now, the x-intercept is always going to take a little bit more work. Okay, so I'm going to explain to you how we're going to do the x-intercept. So for this one, we have -1/2 x plus 4 squared minus 8, and the x-intercept is wherever this equals 0. So this is a quadratic function equaling 0, and we learned this in a previous section. And so the previous section was about, well, how do you solve a quadratic when it equals 0? And you have some options. You can factor it, you can take square roots, you can use the completing the square process, or you can use the quadratic formula. So you're going to look at the quadratic in whatever form it's in and just determine what's the easiest way to solve it. And this one, we had, in theory, to get it into the vertex form, we had done kind of completing the square. And so that's, if you remember, that's the method we're kind of going to use to solve it, is now that the completing the square process is done, we're going to isolate the x. So I'm just going to take this -8, I'm going to add it to the other side. And then I have a -1/2, and you can divide by -1/2 if you're comfortable dividing by fractions. If you're not, you can multiply by -2 to get rid of the -1/2. It doesn't matter to me. So I'm going to go ahead and multiply each side by -2. And then to start to get the x alone inside those parentheses, we need to square root. And when we square root, we always get a plus minus. And I'm going to stop here because this is imaginary. And in the problem, they didn't ask for real and imaginary roots or whatever. They asked for intercepts. And so imaginary roots, they don't show up on the graph. They're not actual intercepts. So if you're getting something that's imaginary, it just means that the graph does not cross the x-axis. And that's what we have a case of here. So x-intercepts, I'm just going to say none. And then I'll kind of prove it to you right now so you guys can see what happened. So we have -1/2 x plus 4 squared with a -8. So the parabola was over here. I'll let you see a little bit more. I need more negative y's. There we go. So the graph was over here, it was upside down, and it was shifted left 4 and down 8. It just never crossed the x-axis, so there's no x-intercepts. Okay, so these are all the different characteristics that we often use to describe a function, and a lot of them don't take much effort to find, but the one that you are going to put more effort into typically is the x-intercepts, and then also in some cases the vertex. So for this one, we have the equation in standard form, so this one is going to take a little bit more effort for us to find the vertex. So here, my a value is 2, that's positive, and so that means that this graph opens up. For the vertex, I'm going to calculate negative b divided by 2 times a. So that's 4 over 4, which is 1. So my x-coordinate is 1. And I'm just going to plug that in to the function. I get negative 11. Okay. The axis of symmetry, x equals 1. The domain and the range, so I've got a U-shaped graph that opens up with a vertex of 1, negative 11. Okay, so the domain from left to right, I've got all the numbers, negative infinity to positive infinity. For the range from down to up, the very bottom of the graph is negative 11. The top is to positive infinity. Max, min. So this time the graph is not going to have a maximum value, and that's because there's just arrows there, so I can't say any specific value. There's always a bigger number that I could say. The minimum value is negative 11, and that negative 11 happens at x equals 1. The increasing and decreasing intervals. So if I put a stick figure right here, he's walking downhill, gets to the vertex, and then is walking uphill. And I can label my x values for my left arrow and my right arrow, and then the x value for the vertex is 1. So the decreasing interval is negative infinity to 1. The increasing interval is 1 to infinity. Okay, and then we just have intercepts left. Okay, so to get the y-intercept, I'll just plug 0 in for x. I get negative 9. And then for the x-intercept, if it's in standard form, I'm going to look 2x squared minus 4x minus 9 equals 0. In this form, remember my options are factoring, completing the square, quadratic formula. So typically I try factoring first because it's the quickest way. So if I was to factor this, I would say 2 times negative 9 is negative 18. So I'd be looking for what multiplies to negative 18 but adds to negative 4. And there aren't any numbers that do that, which means that you can't factor this. And it also means that the x-intercepts then are probably weird decimals. So I'm going to use the quadratic formula. If you prefer completing the square, you could do that as well. So I've got negative b plus or minus b squared minus 4 times a times c, all divided by 2a. Okay, so there's negative 4 squared minus 4 times A times C, 88. Okay, and then the textbook and my math lab, they prefer the answers to stay in this radical form, and they prefer for the radicals to be simplified. So the biggest perfect square that goes into 88 is 4. So that's root 4 times root 22. So that's 2 root 22. So 4 plus or minus 2 root 22 over 4. So the radical has been simplified as much as we can simplify it. We can't touch that. But the 4, the 2, and the 4, those can be reduced. We can divide all of those numbers by 2. So 4 divided by 2 is 2, 2 divided by 2 is 1, 4 divided by 2 is 2. So the x-intercepts that we have are 2 plus root 22 over 2 and 2 minus root 22 over 2. And that is how, unfortunately, that is how they are actually answered. I would love to have you guys answer just the decimal answer, but unfortunately they want you to do the quadratic formula and leave it in the exact form. Okay, so to find the x-intercepts of a quadratic function, you can factor, or using the quadratic formula. Okay, and this is specifically in standard form. Like that first example, if it's in that vertex form, it's a lot easier. You can just start moving the numbers away and trying to solve for x. But if it's in that standard form, then you're going to have to either factor it or use the quadratic formula. So use one of those methods that we reviewed in a previous section. Okay. The last thing that we're going to go over in this video is how to solve quadratic inequalities. And there's two methods, and I think both of them are good. I think it just kind of depends on what your comfort zone is. So the first method is to picture the graph. So what we're going to do is we're going to solve the inequality, and then we're going to use the picture of the graph to kind of help us figure out which portion should be the answer that represents that inequality. So, and you'll see what I mean in a second. So always get 0 on one side. That's still true when we have inequalities, just like when we had equations. So I'm going to subtract the 6 over, and you can see that these two problems are almost identical, except the inequality symbol is different. So I'm just going to show you how they work out a little bit differently because the symbol is different. So when I see this, I would take the problem. I'm always going to try to factor it first. If I can't factor it, then I'll use the quadratic formula. So luckily, this one factors nicely. So we're looking for two numbers that multiply to -6 but add to -1. And the two numbers that do that are -3 and +2. And so those are the two factors that we have. So, and I'm not writing it again because it's the same problem. Okay, so we have two x-intercepts, 3 and -2. Now here, this problem says greater than 0. You can't equal 0, it's just greater than 0. And so I'm going to circle -2 and 3, but I'm not going to fill them in because I can't equal those points. Over here it says less than or equal to, so I'm going to circle 3 and -2, and I'm actually going to fill them in because I can have those points. Okay. And then from there, we know, because this is a positive x squared on these, that this parabola, this quadratic, should be a U shape that opens up. So I'm just going to draw a U shape that opens up. And I'm not worried about the rest of my graph being accurate because I don't care. So I just need this picture. Now I have to decide which part of the picture makes my inequality true. So this inequality said to use the part of the quadratic that is greater than 0. So now they're talking about outputs. What part of the outputs is greater than 0? These have negative outputs, negative y values. These pieces up here have positive y values or positive outputs. So this part right here represents the parts that are greater than 0. This part right here represents the parts that are less than 0 or equal to 0. And so if we were answering this, we would say, okay, the interval notation for this one would be starting at -2, well, not really starting there, but going to the left. Those answers are okay. Becoming more negative, those x values would be fine. And then 3, and then x values that are greater than that would be fine. So we would say -infinity to -2 and 3 to infinity. These are the x values that if you plugged into that inequality, they would make the outputs greater than 0. For this one over here, we're going to do -2, +3, and we're going to say it's a sandwich. All the numbers in between those, all the numbers sandwiched in between those are what would make that inequality true, excuse me, and it's -2 to 3. Right? When you draw solutions on a number line, my math lab has the brackets and the parentheses when they do a number line. It doesn't bother me when you're showing your work if you do circles that are filled in or not filled in, or if you do parentheses and brackets. That doesn't matter to me. So I will give you full credit either way. But as far as what my math lab is allowing you to submit, it's going to do the parentheses and the brackets. Okay. The other method is to use test points. Test points are how your textbook phrases it. Sign chart is how I've heard it elsewhere. So that's what we're going to look at next. This is a typo. It should say 3x. I probably will have fixed it by the time I put this online for you guys to get to, but I just want to make sure that says 3x right there. So again, we're going to make this have 0 on one side. So I subtracted the 3x over, and then if I can factor it, that's always my preference. So for this one, I'm going to look for numbers that multiply to -18. 2 times -9 is -18. I'm going to multiply to -18 and add to -3. So the numbers that do that are -6 and +3. And I'm doing that slide, divide, bottoms up process because I had a coefficient in the front. So the 2 times the -9 was me doing the slide step. Now I need to divide by the 2. So 6 divided by 2 is 3. 3 over 2 does not simplify. And so I'll go ahead and bottoms up that part. 2x plus 3. And so one of my solutions would be 3, -3 halves. So if I were to graph it, those would be my x-intercepts. Either way, those are my points of interest. So this says greater than, so I'm going to put a circle at 3, a circle at -3 halves, which is -1.5. I'm not going to fill those in. Okay, so now using test points, you can just plug in numbers in between each of these intervals, plug them in here, and see if that number is greater than 0 or less than 0. And that's why people also call it a sign chart, because you want to see what the sign is of the output. You want to see if it's positive, so it's greater than 0, or if it's negative, so it's less than 0. So I'm going to choose a value over here, like -4. -4, I'm going to plug in for x, and then I'll just type in my equation. So if I plug in -4, I get a positive answer. So this is positive. Let's see what happens if I plug in 0. 0 is a good number to plug in here. 1 would be a good number. 2 would be a good number. I'll just go ahead and plug in 0. -9, so my output is negative. And then over here, I could plug in 4, I could plug in 5, I could plug in 100. I get 11, I get a positive. So I was interested in what numbers I plugged in would be greater than 0, which ones would be positive, and so these are the ones that are my answer. And so now that I see the signs, I didn't have to graph my answer, but you kind of do it anyway with this one. And so my answer is -infinity to -3/2. And 3 to infinity. Okay, for this one, x squared minus 2x minus 4 is less than or equal to 0. This would have been a simple factoring problem if it factored. I already know it doesn't. There's nothing that multiplies to -4 that adds to -2. So unfortunately, this is a quadratic formula problem. So we have -b plus or minus b squared minus 4 times a times c. Oh gosh, okay. All divided by 2a Okay. The square root of 20 is root 4 times root 5, which is 2 root 5. So this is 2 plus or minus 2 root 5 over 2. I can't touch the root 5. Everything else is a 2, so those are all just 2 divided by 2 is 1, 2 divided by 2 is 1, 2 divided by 2 is 1. So the x values that we're looking at here are 1 plus or minus 1 times the square root of 5, all divided by 1. Okay, I have no idea what that number is, so I'm going to figure out the decimals so I know what test values to plug in. So 3.23, so 1 plus root 5 is right there. 1 minus root 5, negative 1.23. Okay, 1 minus root 5 is over here. Since the inequality symbol says equal to, I'm going to fill those in. Okay, and then I just need to pick values in each interval. So I'll pick -4 again. -4, plug it in for x, and I'm going to plug it into this right here. X squared minus 2x minus 4, positive. And then I'll plug in, I'll do 0 again. -4, and then 5. Okay, and this time this says whatever my values are, they should be less than or equal to 0. And so if they're less than 0, they're going to be the negative, so they're going to be right in here. And so my answer is going to be, I think 1 minus root 5 was the negative. I should have written that down. Ugh. Yes, okay. This was 1 minus root 5. This was 1 plus root 5. Okay, so the answer is the interval from 1 minus root 5 to 1 plus root 5. And as silly as it is, my math lab does not want the decimals for these. It wants the radical answers from the quadratic formula. And so we're going to have that work to be able to get the credit for these.